I am Dr. S. Mahendran, working as professor in the EEE department. In this video, we are going to derive the equation for electric field intensity due to infinite line charge. Let us go to the video. Before deriving the electric field intensity equation, we have to know what is field mean by electric field intensity. It can be defined as the force per unit charge. From the Coulomb's law, we can say force per Q is equal to electric field intensity E. E can be calculated Q by 4 pi epsilon naught R squared AR. AR is the unit vector. It represents the direction. Then we can calculate the AR vector by R vector divided by modulus of R vector. So the formula becomes Q into R minus R dash divided by 4 pi epsilon naught modulus of R minus R dash whole cube. Then we should know what is the charge for line charge, surface charge and volume charge. Here for line charge, Q is equal to rho L into dl. It is a single line integral. Then for surface charge, the Q is surface integral, that is surface integral of rho s ds, which is given in the second equation. For volume charge distributions, the total charge Q can be calculated volume integral of rho v dv, which is given in the third equation. The picture represents point charge, line charge, surface charge and volume charge. From the picture you can see point charge, it is a single point. Then lines, multiple point charge constitutes line charge. If you have multiple lines, then that becomes surface. If you have multiple surface, that becomes volume charge. This is the four types of charge distributions. Then we will move to the electric field due to infinite line charge. Here x, y, z axis are shown in the picture. Then in the z axis we have taken infinite line charge. The distance is minus infinity to plus infinity. There we are taking one point, that is dl 0, 0, z, which is nothing but x axis there is no point, y axis there is no point. In the z axis we have one point at the distance of z meter. The distance is measured from the origin. Okay. Then we have another point P. Another point P which is located in the y direction. The point is located at 0, r, 0, which is shown in the figure. Then in the x direction there is no point. In the z direction we have infinite line charge and one point is located at the y direction. Now we are going to calculate the electric field at that point P. Here the total charge dq is equal to rho L into dl. Rho L is nothing but line charge density. If we multiply the change in length and line charge density, we will get change in charge, that is Q. But the dl is equal to dz. So we can write it as rho L into ds. Then the distance vector r can be calculated, the point of P minus point of Z, nothing but R AY vector minus Z AZ vector. Here AY and AZ represents the direction of y axis and Z axis. Then modulus of r vector can be calculated by using the formula square root of r squared plus z squared. Then we know that unit vector ar can be calculated r vector divided by modulus of r vector, which is nothing but r ay vector minus z az vector divided by square root of r squared plus z squared. Then we can apply this in the electric field intensity formula, that is charge dq divided by 4 pi epsilon naught r squared ar. Here we know that dq is equal to rho l dz. Then we know that ar is equal to r vector ay minus z into az vector. So everything is used in the equation number 3. Then from the picture we can know the electric field produced in the z directions, this perpendicular direction, will be equal and opposite, so cancel each other. So we have only electric field in the y direction. This picture represents we have electric field only in y direction. Here we can calculate the dE, rho l dz divided by 4 pi epsilon naught square root of r square plus z square whole squared. Then the z term gets cancelled because the parallel line will get cancelled. We have only r ay vectors. Then here if you want to know the electric field vector E, we have to take the differentiation, that is from minus infinity to infinity, then the equation. Here it is a complicated one, so we have to use z equal to r tan theta. Then dz can be calculated r secant square theta d theta. Then from the first equation we may write r is equal to z by tan theta. Then we have to change the variable, that is limit value we have to change. Here z is the variable, so z, if z is minus infinity, then theta becomes minus 90. Z is positive infinity, then we will have theta as plus 90. Then E vector can be calculated, that is line integral of minus 90 to plus 90. Then the equation. Here r squared plus r squared tan squared power 3 by 2 simply can be written r cube secant cube theta, which is shown here. Then secant square theta. If we cancel this, we will get 1 by secant theta. 1 by secant theta is nothing but cos theta. So the rho l by 4 pi epsilon naught r will be there. Then the minus infinity to plus infinity cos theta d theta. The value of minus pi by 2 to pi by 2 cos theta d theta is equal to 2. So we have to substitute here rho l divided by 4 pi epsilon naught r sin pi by 2 minus sin minus of pi by 2. Sin minus theta is equal to minus sin theta. So we will get 1 minus minus of 1, which is nothing but 2. So the numerator we have 2, the denominator we have 4. These 2 will get cancelled. So we will have only 2 in the denominator side. So the final equation E vector is equal to rho l divided by 2 pi epsilon naught r into ay volt per meter. Here the ay unit vector represents E vector, that is produced electric field vector towards in the y direction. It means where we have the point, there won't be any component which is parallel to the infinite line. This is the conclusion of this equation. Then we can have one problem to understand the concept in a clear way. A uniform line charge is extended with rho L equal to 20 nanocoulomb per meter lies along the z-axis. Find the electric field at 6, 8, 3 meter. Okay, as said earlier, there is no component in the z direction, so we can leave 3. The only 2 points are 6, 8, which is also taken from the origin, from origin to this area. So 6, 0 ax plus 8, 0 ay. So we will have 6 ax vector plus 8 ay vector. Then we have to calculate the modulus of r. Modulus of r is nothing but square root of 6 squared plus 8 squared, which comes square root of 100. So square root of 100 value is 10. So the radius of the point is 10 meter. We can write the unit vector AR, that is 6 AX vector divided by 10 plus 8 AY vector divided by 10. 6 by 10 becomes 0.6. 6 by 8 by 10 becomes 0.8. So we will reach the unit vector in the R direction. We can apply the formula what we have derived earlier. E vector is equal to rho L by 2 pi epsilon naught R AR. Here we know rho L, that is 20 nanocoulomb. 20 into 10 raised to minus 9. 2 pi epsilon naught 8.854 into 10 raised to minus 12. Then R. R value is nothing but it is 10. So use 10. Then AR vector. AR vector is already calculated, that is 0.6 AX plus 0.8 AY. Now we can have a final equation 10.7853 AX plus 14.38 AY volt per meter. This is the required electric field for the given problem. From the result we can say infinite line doesn't have any component in the electric field, so it lies only in the x-axis and y-axis. Thank you very much for your listening. Thank you.